Hello students, in this video we will discuss the Wumpus World problem in Prolog and the coding that we have to do in Prolog in order to make this program. So let us begin. The Wumpus World problem is defined in the Peter Nordvig book, and what does it say? That there is a 4 by 4 cell board in which there are 4 rows and 4 columns, and in this board there are three types of features. One is a Wumpus, which is a vampire which will eat the anyone who comes to his cell. Then there is gold on some of the cells, which means that if the searching agent will find the gold, he will win the game. Then there are pits on some of the cells, which means that if the agent will enter these cells, he will fall in the pit and the game will get over. And if the Wumpus will eat the agent, then also the game will get over. So there is an agent with a bow and arrow standing at the cell number 1,1, that is the beginning cell, and he has to visit through all these cells, and there are two purposes. One is either he finds gold, or he is able to kill the Wumpus with his bow and arrow, and he has only one arrow. That means he can attempt to kill the Wumpus only once. And if he does not kill the Wumpus, then the Wumpus is going to eat it up. So in whichever cells Wumpus is there, there is a stench in the adjoining cells, which means the agent can identify from the stench that there is a possibility of a Wumpus in the adjacent cells. And wherever pit is there, breeze is there in the adjacent cells. Like here we have a pit, so breeze is there in all three adjacent cells. Here pit is there, so breeze is there in all four adjacent cells, like that. And for gold, whenever the agent is going to find gold, then the glittering property will turn true. So this is the original Wumpus World problem, which is defined in the Peter Nordvig book. Now let us look at the Prolog code for dealing with this Wumpus World problem. So before we actually begin the Wumpus World problem solving, we have to define the various parameters which we are going to store in the database in the Prolog environment. So we will not create a knowledge base explicitly, but as the program is going to proceed, the knowledge base will be updated in the memory of the Prolog itself. So what all we will use? We will use agent location with one parameter, gold location with one parameter, pit location with one parameter, time taken with one parameter, score, visited, which cells have been visited, we will maintain a list. Visited cells is there. Then world size, that is what is the size of the world, it is 4 by 4. Wumpus location, and then we have whether pit is there in the next cell, Wumpus is there in the cell, or gold is there in the cell. So these are the various parameters which we are going to use in the database of the Prolog. Now before the game will begin, we have to initialize the various parameters which we have just discussed. So there is a function init which we will call in the start predicate of Prolog. So in init we will initialize the game. How we will initialize the game? We will set the score, time taken, what are the visited cells, whether Wumpus is there or not, like this settings will be done. Then various LAN configurations, where the pit will be found, where the gold is there, where the Wumpus is located, that is set in the LAN configurations. Then agent, where the agent is there, his location will be updated, and then Wumpus location will be updated using the init Wumpus. So here you can see the declarations. In init game, we will first of all clear the memory. Retract function is used to clear the memory of all the previous settings for this particular parameter. So we will clear the time taken, and then we will assert the time taken as 0. Every time the game will be started, time taken will be initialized to 0. Then score, whatever old values are there, we will remove them and set the score to 0. Visited, we will set the score to 1. Then is Wumpus, we will retract all the values. Gold also we will retract all the values, and visited cells also we will retract the values and re-initialize with an empty list. so that now when we will play the game, then the new cells will be added here. Then in init land, we will set the world size to 4. Gold location is set to 3, 2. That means third cell and third row and second column. Then pit location is located at 4, 4. Another pit is at 3, 3. Another pit is 1, 3. Agent is located at 1, 1. And Wumpus is located at 4, 1. So this way we have set all the parameters. And then the visited cells, we have the old value ys, and then we will retract the knowledge base of the visited cells and then reassert that the visited cells is ys plus xs. Xs is passed as an argument here, and that will be appended along with the old value of the visited cells. So this is what we will do in the initialization of the game. Then we have to define what are the adjacent cells. So 1 is adjacent to 2, 2 is adjacent to 1 and 3, 3 is adjacent to 2 and 4, and 4 is adjacent to 3. So this way we have defined the adjacency. Now we have to define for the row and column configuration. So if x1 is equal to x2, then we have to check the adjacency of y1 and y2. And if y1 and y2 are equal, then we have to check the adjacency of x1 and x2, because every time we make a move in a grid, only one, whether the row will change or the column will change, both cannot change at the same time because diagonal moves are not allowed. Then we have to set the configuration for stench, which is smelly, breezy, and then pit, whether we have to check whether a location is breezy, smelly, or has a pit. So is smelly, we will pass the location here. Then Wumpus location is ls2, and if adjacent location of smelly is adjacent to location of Wumpus, then we will return that the is smelly is true. Then is breezy also, pit location is adjacent to the breezy location, then we will say that it is true. Then similarly for glittery, we will pass one location, and we have a gold location with us in the database, and then if x1 is equal to x2 and y1 is equal to y2, that means the gold is there on this particular cell. Now breezy, we have defined one predicate. It is yes if agent location is given and breezy is also at the agent location, otherwise breezy is no. And similarly we have defined for smelly and glittering. Now we have to update the knowledge base dynamically. So we are passed with the parameters of stench, breeze, and glitter. And if a cell is stench, then we have to add the Wumpus in the knowledge base. If the cell is breezy, then we have to add a pit. And if the cell is glittery, then we have to add the gold. So what we will do, we will add Wumpus no. If the parameter of stench is no, then what we will do, we will take the agent location and we will mark all the adjacent cells as not having the Wumpus if the stench is given as no. Then if the pit parameter breezy is given as no, then we will mark all the cells adjacent to the agent location as not having a pit. And if the breezy is given a yes, then what we will do, we will mark all the cells adjacent to the agent location as having the pit as yes. Then similarly, if the gold glitter is no, then in that case the gold location is different from the agent location, and in case it is given as yes, then the agent location and the gold location will be the same. Similarly for Wumpus also, yes and no are there. If stench is no, in that case we will retract all the previous values of the Wumpus and we will say that there is no Wumpus in the cell. And then if yes is passed, then we will say that the Wumpus is there. Similarly, we have parameters for pit, we have for gold, and we have for whether we are permitted to make a move or not. This is to control that we do not run out of the board locations. And all these parameters, they are called during the execution of the program to change or to guess whether in the next cell there is a Wumpus or not, there is a pit or not, and like that. Then there are step taking process. First is the pre-step taking process and then is a take step. In pre-step taking process, we will assert all the, we are not asserting, but we are getting all the parameters that are stored in the knowledge base, and then we will see whether the agent location is same as the goal location. We will print that you have won the game. If the agent location is same as the Wumpus location, we will print that the Wumpus has eaten you. Otherwise, we will call the take steps. In take steps, we will make a perception. This perception variable will be passed to the system, whether there is a stench or not, whether there is glittery, whether there is greasy, and the agent location will be passed to the system. Then we have to update the knowledge base with the perception. We will update the parameters for greasy, stench, bleasy and all, and then we will ask the knowledge base what action should be taken for the visited list. So basically we will find the new location and what action we are taking, and we will print that action on the screen. So in this we are updating the time, we are updating the score, we are checking for the agent location, adding that agent location to the visited list. Like that we are updating and taking the step. Now in order to start the game, we have the start predicate. In this we will first call the init and then call the take steps predicate. So with this we can execute the game and see the results for ourselves. Let us see how it will work. So as you can see here, we have to type on the prompt start, and as we type start, it will start initializing and play the game, and it will say that this agent is in the 1,1 cell, and initially when he finds out there is no stench, there is no pit, and there is no glittery. So for each of the adjacent cells, it will find out whether there is gold, there is Wumpus, or there is a pit, and like this it will proceed, and finally it will reach the answer. Let me show you. So as you can see here, in the end it is telling that it is going to enter here, and there is still something to do, and it has won.